In 1998, Intel released the Celeron Mendocino as a lower cost option to the Pentium. The cool thing about these CPUs was that they are SMP capable, allowing two CPUs to work together on a single motherboard. Being a low-cost option, Intel wasn't likely expecting manufacturers to find out and take advantage of this feature. However, ABIT did and released the SMP-capable ABIT BP6. In combination with its overclocking capabilities, the ABIT BP6 is an absolute legend among vintage motherboards. Unfortunately, it wasn't meant to last because the BP6 was manufactured during the early days of the famous cap plague. Most if not all BP6 boards died an early death with bulging and leaky caps. This board is no exception, so today we're going to see if we can repair this epic motherboard. Unfortunately, these boards also have a minor design flaw. The caps are too tall and sitting too close to both CPU sockets to allow for proper heat sinks. They are also out of production and only even larger caps are available nowadays. So in this video we are also going to try out something new. A method to get around this problem that nobody seems to be using. Perhaps for a good reason. I guess we'll find out in a few minutes. Most of the caps on this board actually still looks good. But I can assure you they're not. The only cap that is showing us a clue to what's going on here is EC14 here. It's clearly bulging. And the electrolyte has started to come out. At the back of the board, all the ports are pretty heavily corroded. So I'm going to replace the PS2 port and the USB port. Unfortunately, I don't have a complete assembly to replace this part here. So we're going to have to restore the parallel port and the two serial ports and see if we can make them look nice again. To prevent the white plastics to get discolored, I'm going to protect them with some Kapton tape. This is not strictly necessary, but sometimes white plastics go yellow with enough heat. I like to keep my white plastics white, especially on a rare board like this. Okay, board ready to get toasty. So next up I'm going to mark all the caps on this side of the board to make the removal of the caps as quick as possible. Next we can install it in the preheater. Oh wow, it just about fits. There's only 2 millimeters left to the edges, so it can still move if it needs to expand. Next we need to tape down the thermocoupler, one on each side of the board. This way we can see the temperature on both sides of the board. The second thermocoupler is going to go right here in the middle of the board. Let's turn it on. And I'm going to go with 130 degrees Celsius. I think that should be enough for this board. You don't need a preheater to recap one of these boards. You can just use the cheapest heat gun to have at your local hardware store. But if you do, make sure to heat up the entire board every time you heat the board. And not just the area where you're working, otherwise you're going to warp the board. Okay, I'll wait for it to reach the temperature and skip ahead here. This preheater overshoots about 15 degrees Celsius, but after a few seconds it goes down to the set temperature. So underneath we are at 145 degrees Celsius now, and on top of the board we are at 80 degrees. So within a minute or so we should be down to 130 underneath the board and at around 100 on top of the board. Okay, that's close enough to get started. Let's remove some components. Okay, I'm gonna start with the caps in the middle of the board and let the edges heat up some more. Yeah, the caps are just falling off the board. Well, actually not this one. Well, I was expecting some of them to be a bit stubborn. But I'd rather not go higher in temperature. Now that is a pretty sizable ground plane, so I'm gonna give this one a few more seconds. Now, still some solder left. Let's try another one connected to this ground plane. Yeah, still some solder left in that through hole. Well, in that case, I'm going to add some fresh solder before we continue. Okay, let's see if that helped. Yeah, definitely did. Yeah, that totally worked. Adding some fresh solder makes a huge difference. Yeah, this is going pretty well. So I'll desolder a few caps in the middle of the board here and skip ahead. Some of the caps in the middle of the board required some fresh solder twice. The caps that fell off the board still left some solder in the through holes. So I'm going to add some fresh solder into the empty through holes and have a second go. Yeah, some more fresh solder totally solved it. Now let's see if we can clean out one of the empty through holes with just solder. Yep, that totally worked. All the through holes, except for these two guys here, cleared out really nicely. But for some reason these two are really stubborn. So let's try with some desoldering needles and see if this helps. So these are just stainless hollow needles, and they are designed to remove solder from really stubborn through holes. But apparently that's not enough for this board. So I'm going to try to reflow them again. So let's add some more fresh solder. And then I'm going to use the desoldering gun and my pine sill to add some extra heat to that pad. Oh, I think that cleared out. I'm not sure. Let's try the other one. Finally, that cap fell out. And the through hole is clean from solder. Wow, that was a stubborn one. Well, there were two more caps. Just as stubborn, but I used the same method. So they are now off the board too. Now let's see if we have enough heat at the edge here. Yeah, we totally do. That cap just fell out. The board is slightly cooler towards the edges. Caps near the edges tend to require less heat. So this is totally working. The fan in this preheater makes an incredibly annoying noise. So we're gonna have to make a mod in a future video and install a much larger fan. Oh, still some solder left in some of the through holes here. So I'll add some fresh solder and try again. When I'm not sure if the cap is loose, I like to use the desoldering needle and push the cap out. Well, still some solder left, so I'll reapply some fresh solder a second time. Okay, the last cap fell out, so all we need to do now is to clean out those through holes. Pretty stubborn board. 130 degrees is a pretty low temperature, but still, I was expecting it to be a bit easier than this. I should probably try 140. Maybe next time. Okay, all the caps have been removed. Let's remove that PS2 connector. So, knowing that this board is a bit stubborn, I'm going to add some fresh solder right away, before I even try to desolder it. Same thing with the USB ports. Okay, let's see how easy this connector is to remove. Well, a lot easier than the caps, that is for sure. But it also has some pins that are too large for my desoldering gun. So this could be a problem. Yeah, definitely not enough. So I'll add some fresh solder and have a second go. These pins are huge. Well, in that case, let's try to heat this pin up with a pine sill and then use the desoldering gun. Yeah, that made a huge difference. I think this is working. I try to wiggle these pins as I desolder them, and hopefully that will also make them unstuck. Well, stubborn or not, I think that USB just came off. Awesome. But that PS2 connector still needs more solder. So I'll try the same trick and add some more heat with the Pinesil. Okay, at least some of these large pins are now free. Actually, I think all of them are. Except for this little guy here. So let's add some more fresh solder. And then remove it. But I don't want to use any force, in case it's still stuck in something. But I think it's free. And here it is. Finally. That was a really stubborn connector. So next I'm going to lower the temperature to 50 degrees Celsius. And let it cool down slowly. Okay, the board has cooled down. Actually, it's been a few days. Because I had to travel in my day job. And I got stuck at a bloody airport on my way home with cancelled flights. So this board had plenty of time to cool down. At least I got to watch plenty of YouTube. That's always a good thing. Well, whether the Kapton tape made a difference or not, all the white plastics are still white on the board. Now let's move on to our cap experiments. So here's our problem. This board will take the stock Celeron cooler because they are so small. However, if we try to use something larger, like these golden orbs, these caps here are preventing the cooler to touch the CPU. So this is a very annoying limitation of this board that I think we might be able to fix. So I measured the lead spacing and it's about 3.4 millimeters for these caps. So then I went ahead and checked some datasheets for SMD caps. And I noticed this measurement here for these Nippon Chemicons are 3.1 millimeters. So I went ahead and ordered some of these. Now let's see if we can hack these to fit our board. So here's what I'm thinking. What if we bend these leads up like this and remove the plastic base? Well, that kind of looks like a through-hole cap to me. So if I move in as closely as possible, you can see that these caps are quite similar to through-hole caps, with just two round leads coming out underneath. But then they seem to have been pressed and are no longer round. This also means they are slightly too wide. So I'm going to use my Dremel and make them slightly thinner. I don't think you need to use a Dremel for this, because I think these leads are made of aluminium. So you can just use a file or whatever you have at hand. Now let's see if this crazy idea works. It does. It fits perfectly. Now that is a snug fit. I went ahead and hacked a few caps. They fit perfectly. I don't actually think I measured the width of these caps, but apparently I'm lucky. Check out these two guys here. They are perfect size. And with these small caps we can obviously install whatever heatsink we want. And it looks absolutely pro. You couldn't really tell that this is a hack. With the plastic base removed, these leads are perfect length. I don't get it. Why isn't everyone doing this? This is an awesome hack. I hacked the remaining caps and they all fit perfectly. I'm only going to use hacked caps close to these two sockets here. For the rest of the board I'm going with regular through-hole caps. When it comes to size, the only critical two caps are these two. So don't go wider than 8.2 millimeters. In between the two sockets we have a 1500 microfarad 10 volt cap. These are 6.3 volt caps. So this 10 volt cap here is slightly larger than the original caps we had here before. But compared to these more modern caps, this thing here looks huge. It's more than double the size. Okay, all the caps have been replaced and soldered. I ran into a minor problem with E26 here. I didn't make a list of the caps, and instead I used the list on badcaps.net. But unfortunately that list is missing E26, so I had to guess here. So if you're recapping one of these boards, check E26 before you remove it. Okay, next we need to restore the ports at the back here. I think this stuff here is just baked in dust on this side of the connector. However, this stuff here is definitely rust. So let's restore these connectors and see if we can make them look nice again. So first we need to remove all the standoffs. And then we need to drill these rivets. And now I think we can pull the shield off. Well, a bit trickier than I thought. But there we have it. Now we can install a used but much nicer shield. I'm not going to replace those rivets. These standoffs are going to do the job good enough. Yeah, this looks much nicer for sure. I'll do the same thing with these two shields off camera. Well, that turned out to be a lot harder than I thought, because these nuts at the back here, they are loose. So when I removed the shield, they fell off. They are easy enough to reinstall in this hole here, and same thing on this side here. But these two guys in the middle, they are pretty much impossible to reinstall. Well, to make this a little bit more interesting, let's remove that connector with the cheap heat gun method. You still need to fixate the board somehow. You can't just put it on the bench, because then it will get warped. I think the easiest way is just to use some very long standoffs and use the existing screw holes on the motherboard. So I'm just going to use the cheapest heat gun they had at my hardware store and heat up the entire board. Not just the area that we are working on, but the entire PCB. Otherwise it's gonna get warped. This heat gun only has two modes, low and high, and I have it set to low. Okay, I skipped ahead about 30 seconds. The board has now reached 100 degrees Celsius. And now we can add some fresh solder to the connector that we are going to remove. Especially these large tabs. And the board dropped down to 60, so I will apply some more heat. It's not a big issue if your board gets bent or warped. It will most likely still work, but it doesn't look great. I'll use the same method to remove this connector. I'll use the desoldering gun and add some heat with the pencil. And for the remaining pins, I'll just use the desoldering gun. Okay, the board dropped down to 60 degrees. And the desoldering isn't working anymore. So I'll reheat the board back up to 100. Okay, that was still not quite enough. So these remaining pins here are probably connected to ground. So I applied some fresh solder. And I'll reheat the board to 120. Okay, said and done. Let's try again. Yep, that totally did the trick. The solder is coming off from these stubborn pins too. The temperature dropped to 80 and it stopped working again. So we need to keep it above 100 degrees Celsius for this to work. Okay, I did the same process again. And as soon as it dropped below 100, it stopped working. So I still have two through holes to clear out. So I'm gonna have to heat up the board again. Okay, finally, the last pin has been desoldered. So as you can see, it's very tedious, but it's definitely doable. And if you're just doing one board, this is the best method. I checked underneath, and apparently I had to desolder this pin here too, to free up the parallel port. So that has been done. Okay, let's see if it will come off now. Yes, I think it's free. It is. And completely baked in dust. But that will come off in the wash. So yeah, this method definitely works too. I'll reinstall the two nuts at the back. Now we can install nice and shiny shields. I did a quick test with a cable and made sure that these shields are aligned. I'll apply some flux on these nuts. And I will lock these nuts with some solder so they can't come off again, in case one of the standoffs will come undone. Okay, the parallel port has been soldered back on. I have to say, replacing those shields is kind of worth it. It looks much nicer now. So next we can install 2 USB ports and the PS2 ports, of course. The only thing left now is to solder these connectors, and then I think we're ready for a test. Okay, let's drop a Celeron into that ZIF socket. This large cap here looks kind of silly. I should have used a hacked cap here too, purely for aesthetics. The original cap is much smaller, but this is a recommended upgrade on badcaps.net. Oh crap, I ran out of heat paste. Actually not, there's still some left, but it had gone all hard. But with some heat it got soft again and came out. I guess it's a bit too old. I'll toss it and buy some fresh heat paste. We are going to need some RAM, of course. And a fresh coin cell. And a period correct graphics card, of course. Okay, power and display connected. This should be sufficient for a post. Fingers crossed. Okay, the fan spins up in the power supply. And golden orb too. We've got some high voltage. Yes, it posts. Awesome. This BP6 is back to life. It recognizes the Celeron and RAM. Okay, keyboard added. Let's test again. This is awesome. We have a working system. I think we have a Celeron 466 installed. So let's change this. I have ordered something faster for this project, but for now let's just save. I installed a hard drive, diskette drive, CD-ROM drive and Windows. As you can see, it all works fine. So I guess we now have a perfect method to replace obsolete caps that are no longer manufactured. Spread the word. Okay, so next I'm going to give this board a proper wash and get all that baked in dust and flux off the board. And then we're going to build a custom period correct 1999 Dream Machine with this board. I think I have all the parts required, but I'll check an order if needed. When it's done, I'll put a link on the screen to that video shortly. If you're watching this fresh, hit the bell icon below and set it to all. Meanwhile, check out this video about this Dream Machine from 1990. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.